bolt, that's the factory image out of the manufacturer's catalog. Transom bolt, that's your finish. We're in antique nickel. I don't want antique nickel. It doesn't really matter. Allows a pair of doors to open and close together to gain full use of the entire opening without the necessity of releasing and securing or releasing and resecuring the inactive door after every operation. Transom bolts are especially ideal for small double door situations such as bedrooms, master baths, closets, French doors, patio doors, and offices. Commonly used on interior doors, but can be utilized for exterior doors or any doors where UL fire rating is not required. This really needs to say commonly used on interior and exterior doors, and on any openings where UL fire rating is not required. I'm gonna get that correct. I'm gonna change what the factory puts there. It makes me feel like smooth operation, easy installation. Yeah, I agree with easy installation. Ball catch on top of active door is easily adjustable with screwdriver to account for variation of door to header clearances. Available with double ball catches for push-pull operation. Specify 04DC. Interesting. Okay, let's take a look at the images of this item. There's the box. Here are the contents. You pull that finished plate off and you're going to get to you'll see it on the video, I suppose. There'll be a couple of holes in here for the fasteners, for the body, or for the plate, really. Yeah, right in here. It's probably here and here. Me showing when I depress the ball that bolt drops down. The strike for the top of the active door. And then the rest of everything else that you get. Now, let's take a look at the extended description. Cell sheet. That's probably just going to be a cut sheet. There we go. 04. There's your 04 transom bolt. All of this is in the extended description. We won't go over that again. Giving us all the dimensions here. Nice. Okay. It's a good piece of documentation. Cut sheet. How is this different? Okay, this is out of their catalog. Cell sheet and cut sheet. There you go. Giving you some more an idea of how that's all installed. You know, where to install it? I can tell you. Inch and a quarter. Oh yeah. Okay, so where to install it? What I would be doing is probably putting it in the center of the opening, because this is inch and a quarter from the end, and so is this, and the dimension of the plate, this and this, are likely the same. Oh, and they are 2 and a quarter. Oops. Yeah, so 6 3/4. What's that going to be? 3 3/8. That makes sense. Yeah, 3 3/8. So I would probably find my center line of the door. I would determine my gap between the doors. I would then go over 3 3/8 minus inch and a quarter minus the gap. That's where I'd strike my center line here and here. And the rest is history. I suppose you could skew it one side, you know, make it biased towards one side. I don't know why you would want to. Okay, yeah, it's a template. Here we go. Well, this is going to make life a lot easier. A lot easier. I mean, all I was going to do is measure this. I didn't know this document existed. So, center line over, sure. I was measuring off the edge of the door, and I was taking half of the clearance between the two doors. So super easy. But this is really the question that the client has. How to prep it? Well, it's really, really, really easy. It gives us everything we need to know. So let's 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 go into the CAD CAM software and let's take a look at it. Okay, before we jump into the CAD CAM software again, what we need to do is to replicate this prep. We're looking at the underside of the header and we're looking at a cross section of the header. Or pardon me, we're looking at an elevation view of the header. I had mentioned early on, and to the customer, you have a plate prep and you have a body prep. That's all of this. It's two rectangles. Just think of it as two rectangles. Unless otherwise noted, they are basically centered on each other. Okay, they're not biased towards one side like a a concealed door closer, a hydraulic door closer would be. Half of the thickness, I don't know about that, because I would take the rabbet and I would then determine what the inset is at all. I would need to have the center line of my rabbet and the center line of the door to be the same. But if I take half of the door thickness, does that mean to measure from here? Well, what if the door is inset 1/8 of an inch?
AV supply.
So that could be problematic. Okay, let's set ourselves up a job here to cut this header for the transom bolt. So let's create a new file. And, the single-sided job. Now, if I was going to actually prep a header, um, what I would end up doing is positioning my tool pathing at the proper distance from the edge of the header over. And I'll do that here as well, just so that it'll look kind of reasonable. You know what? In the sense of that, let's just make this 4.5625. And it's 4 9/16. Now the height of 30-inch, let's just assume that this is a pair of 7-foot doors. Pardon me, a pair of 3-foot. Well, more realistically, 2'8". So what we'll do, so that's 32-inch each door. What I'm going to do is I'm going to say that this is 48-inch because that's actually the limit of my my y-axis. Okay, and then what I'll do is I'll position my tool pathing. Let's do this. Let's say this will be good. All right. All right, check it out. So 4 9/16 wide, 48 3/4. I'm going after a pair of 2-foot doors. Sound reasonable? Let's go for that. Now the thickness. I'm going to go and actually put a caliper on the material just so that I have an accurate thickness. So I'll pause this, and when I come back, we'll have that. Okay, I went over through the caliper on it, and it's 0.724. At the end of the day, it really doesn't matter for what I'm doing because I'm going to zero off the workpiece, off the top of the workpiece because my depths are going to be the plate and the body that I've been talking about. So the zero position, yeah, material surface. I'm going to zero off of the top of the plywood. My my datum can be 00. That's fine. Modeling resolution, that's good. Let's go with a birch. Okay. Okay, so that sets the material up in terms of what we're. So what we have to do now is a little bit of math. So this header is 48 and this header is 48 3/4. That's because I would put a 3/8 rabbet here and a 3/8 rabbet here is what I would end up doing for the jamb. So what that means is I'm going to want to be in the center line of this board. So that's going to be 24 3/8. So I'm going to put a dimension line at 24 3/8. There's one right there. Now I'm going to grab, and what I'm doing is locating where I'm going to place this piece of hardware is what I'm doing. And I'm going to use these dimension lines for doing so. I'm going to give myself a dimension line at 1 7/16. And that's because my rabbit's going to be 1 7/16. That's going to be where my rabbit is. Okay. My door, which is 1 3/8, and the door is not actually 1.375, but for purposes of this, it's going to be 1.375. Meaning the door will actually be a little bit smaller. I'm going to bring another dimension line here, showing the face of the jamb. I'm going to bring another dimension. So we've got 1 7/16. I'm sorry, I did that wrong. This needs to be 1 9/16. 5, 6, 2, 5. Apply. And that's 3/16 larger than the door itself. Well, that's because the door is going to be inset slightly. So I'm going to create a new guide offset at 0.096, close, and then I'm going to create a new guide at negative 0.096. So I'm taking my rabbit and I'm simply saying this is going to be where my actual door is going to reside in the opening. A 3/32 inset and 3/32 between the face of the door and the face of the stop. Okay, now that gives me a center point here. This dimension should be 1 3/8. So let's measure that. And I apologize. It's been a good 2 months since I've played with VCarve. I've been on vacation. Yeah, this is 1 3/8. Okay, so my door is going to occupy this space. Now we know that the hardware is 6 3/4 by 3/4. We remember that from our earlier um, work. So 6 3/4 by 3/4. So let's do this. 6 3/4 times 0.5. I realize this is simple math and I can do it in my head all day long, but I really, really, really like to be sure. 3 3/8. Yeah, of course we knew that. So what I don't remember is how wide. Oh yeah, it's 3/4. So 3/4 divided by 2 is 3/8. So what we're going to do here now is I'm going to now outline my plate prep, which means I'm going to create a new position, a new guideline at 3 3/8 relative to the center line. Great. Now I'm going to create another one, negative. Now you're starting to see what we're doing here. Now I'm going to create a new here's what we need now. What I should have is this here rectangle should be 3/4 by 6 3/4. Wait a minute. No, it's 1 inch wide. Yeah, this is 1 inch wide, not the okay, so let's do this. I'm second guessing the size of my faceplate, so let's pull up the template from the website. That was a accurate LH04. Can pull any of them up. Yeah, it's 1 inch. Yeah, forgive me. 6 3/4 by 1. Okay, well, at least we didn't run 100 of these. So let's fix this. That's an easy fix, of course. So we're just going to move this. Not sure if this will work, but let's try it. So we went from 3/4, so minus 0.125. We got to move that out. It didn't appear to work. Let's get rid of this one. Oh, let's get rid of our two guides. So 1 3/8. Inch and 3/8 minus 1 divided by 2 is going to be 3/16. Yeah, okay. 3/16. So let's create our new guidelines. Relative 0.1875. Create new guide. Close. Relative minus. Create new guide. Close. Okay, now this box here should be 6 3/4 by 1. Let's measure it. Yeah, that looks good. That looks good. Okay. So now what we're going to do is we're going to draw a rectangle. There we go. Let's turn off our guidelines. That's our plate prep. It's got the right size. The width is a little small, like really, really little small. We're going to leave it. The X position, 0.2835, which would be 0.096 plus 3/16. 0.096 plus 3/16 would be this. Then 21 is going to be 24 3/8 minus half of 24 3/8 minus 3 3/8, which is half of 6 3/4. So that all looks good as well. And I'm doing a reality check on this. I'm going to change that to 1 since this is what it actually needs to be. I'm not sure if it stretches it in both directions, but that was an incredibly small number, so I'm not worried about it. Now that's going to give us our plate prep. That's our plate prep. All I did was draw the plate prep first. Now, um, uh, 1/4 inch radius, which means a 1/2 inch bit. So yeah, you can use a 1/2 inch router bit for doing all of this work. And out here, you're going to square the corners. Inside, you won't. So this, this is now, okay, so what is that, 13/16? And then 5 1/8. So guess what we're going to do? We're going to go back and we're going to grab some more guidelines. So what we know we're going to need to do is we're going to need to create new guidelines here. So I'm going to leave my original guidelines. Sometimes it gets confusing, but let's just try to not get confused. So we knew that the template called out 5 1/8 for the height. So let's do that first. 5 1/8. Okay, fine. So from here, okay, so what we have to do is, I should have a calculator on the screen. I am using this as a calculator. So 5.125 divided by 2. So 2 9/16. Okay, great. Relative minus 2.5625. Create. I didn't need to do that. And then positive. Delete, create, close. Now I got these two inner ones. Now I'm going to need the guidelines for here. That's 3/16. 3/16 divided by 2. It's actually 1 minus, yeah, it's 3/16. I was doing the math in my head. So 1 inch minus 13/16 is 3/16. 3/16 divided by 2. Okay, so 1 minus 0.8125 divided by 2. Oh, 93 thousandths. Yeah, and I made a mistake. I made it 0.96 before. That's where that difference came in. That 5 thousandths of an inch came in. It's 0.093. I'm not going to go back and fix it. 0.093, 09375. So we're going to create this guideline, relative, 0.09375. Create, close, relative. It's nice that it saves the value. Negative. It's rounding it. That's fine. Close. Okie doke. We need one more rectangle on all of our inner stuff. Let's do that. Rectangle. Turn the guidelines off. Now, because we'll use a 1/2 inch bit, or maybe I won't. I'm not sure what I'll use yet. Let's take this. Let's move it. Oh, let's move that to a new layer. I'm going to call it body. Okay. Now, guidelines are off. On that construction layer where I was doing the drawing, it's not there. There's my plate. There's my body. Does not. Okay. I guess it looks okay. When I was here, this did not. I'm doing a reality check with my eyes. That didn't look even. So let's continue with a reality check. Just 0.0938. Yeah. It's accurate. And since we're in the business of doing a reality check, 0.8125 down here. Yeah, okay, so we're balanced. We're good. Bring those lines back in. Now you can really see how guidelines really helps. And I didn't teach myself that. Chris Burns from ShopBot taught me all of that. So now what we get to do is do our tool pathing. And let's call in our tool pathing. Let's pin that. Let's get to work. Okay, so we've got our CAD side here and our CAM side here. So I'm going to turn off our guidelines. And we know that we're doing a body prep in here and a plate prep out here. Let's go back and review what that is. So let's turn the template back the way it's meant to be seen. Okay, so really, really easy. We've got to go 1.5 inch deep. Well, our plywood that we're using is basically 3/4. So we're going to blow through it. I'm going to go through it, but I'm only going to set the depth to like, whatever, 0.8, 0.75, 775. I don't need to blow into my spoil board so much. So we know the depth, but the plate is 3/16. So this becomes really easy. This just becomes 2 pocket preps. You know that when you're going to install this, you're going to have to go into the header. I would personally use a fly bit for that. That's 13/16. Yeah, I'd probably strike a center line down my header, and I would get a 3/16 bit And I would just drill and drill and drill and drill and drill and drill and get to where it was all good. Then um, I would chisel out those corners. You get the picture, right? You're gonna chisel all that flat. Then, I mean, you're good at that point. You're not going to do any mortising. You're just going to use a fly bit for all of the body prep. That works. My suggestion, absolutely. What I was going to suggest was that when you're doing this up in the header, drilling all this, making all this mess, have a shop vac and have someone there holding it. Collect all that dust and wood chips as it's being created, not after the fact. Capture it right at the source. So that's what that's going to do. Okay, now CAD CAM time. So I said we're going to do the body first because I'm using a router. I'm going to route this. So I'm going to select my vector and I'm going to do a pocket toolpath because that's what we're doing. Our start depth is 0. It's at the top of the material. And our cut depth, the template says 1.5. My header is only 3/4. So I'm going to go in 0.775 because my material measured 0.725. I'm going to go 50 thousandths deeper to get through it. Um, okay, so I've got a down spiral here. Uh, I'd like to use an up spiral. I'm not sure what bits are easily here though. What I have easily at my disposal. Let me look at my rack and see what I got sitting there. Yeah, the down spiral bit that I've got in here is bit number 3. That's tool number 3 in my rack. And I'm going to use the down spiral because I want a clean cut. It doesn't really matter for the body prep at all, but I want a clean cut. So I'm going to use a down spiral on this. And, um, I have used this bit over and over again, cutting wood. So I'm just going to leave all the settings and I'm just going to select that bit, is what we're going to do. We'll do a climb cut. That's no problem. We're going to call this tool body. That's what we're doing. 4 passes. So 3/4 divided by 4 is 3/16 per pass. I'm a fan of taking it easy. This is no big deal, but it's basically an eighth of an inch a pass. That's fine. I'm in no hurry. This is just the first time I'm doing this. We'll tweak it. We'll optimize later. It's telling me I'm going to cut through. Yes, I know I'm going to cut through. I want to cut through. I need to cut through. So that's our body prep on that. Oh, that is awesome. Check that out. All right, let's not get too excited. Let's go back and um, that's our body prep. Cool. And let's just go with our plate prep now. Uncheck that toolpath. Plate prep. Let's select the vector. And close. Selecting that vector. It's also going to be a pocket. Cut depth now. This is going to be 0.1875. 3/16, right? I think so. Yep. 0.187 is what that should be. 3/16. We're going to use the same down spiral. We're going to climb cut. Down spiral. Down. Yeah, that should be good. 1 pass? Nah. In no hurry. Clean. 3 passes. We're going to call this plate. That's how I like to call it. That's how I learned to call it, I guess. We're going to calculate. Awesome. So there is our plate prep. So now I could sure make life a lot easier in the sense that when I do my body prep, I'm going to be I'm going to do my body prep first. When I'm doing my plate prep, I'm going to be cutting a lot of air in here. I could go back and tweak all my tool pathing so that I'm not wasting. I could just skip over that, but for goodness, I would in a production setting, I would absolutely optimize this, but I'm not investing the time to optimize this. So let's preview all tool paths. Let's go to our 3D view. Let's reset the preview. Our toolpaths are highlighted. Let's preview all toolpaths. Okay, so it runs. Body first, plate next. Okay, so let's do this. Let's now reset our preview, select all of our toolpaths, preview selected toolpaths. It's literally showing the tool as it cuts. Oh, that's just plate. I only had the plate highlighted. So let's reset. Let's select. Let's slow down what we're doing. And let's preview all toolpaths. Now it's showing it cutting through there. Yeah. That looks fun. Again, this is just the body prep. This is a 1/4-inch diameter bit, which will leave you with 1/8-inch radius corners. You're probably not going to, you won't need to square out the corners on the body prep at all. Move that while we're doing it. Now we're through. Now, no tool change involved. We're now, and what you're seeing here is because the tool is cutting air. There we go. I would obviously be looking to optimize that. Cutting air, cutting air, cutting air, cutting air, cutting air, cutting air. There it goes. Cutting air, cutting air, cutting air. That might be the second pass. Now it's got to do a third pass. And I have this on the really slowest speed so you can see it. If I put it on the fastest speed, it would have been done many, many seconds ago. Nice. That's what your prep's going to look like. Then you're going to go in and square these corners. Okay. And that's going to be easy peasy. I'd obviously be testing or optimizing speeds. I'd want to move through this, but I want a really high quality finish, meaning the veneer. That's what I'm talking about there. But this looks great. So the next thing to do at this point is to save these tool paths and then run it to the machine. So let's get started. Let's do that. So now the next thing is for me to get the CNC machine up, running, spindle warm up, zeroed, compressors, all that stuff running. So the next thing that we're going to end up doing is I'll go through all those steps and then I will switch the camera view and show you exactly where we are at. So let's get the machine up, ready to cut. Okay, we're going to get the machine set up. You're going to just watch the overhead view, I suppose, while I go through and do this. So this is going to be not much of just watching an overhead view of me setting up the machine. But at a very minimum, I can at least narrate as we go through this. You can see that I've got the piece of wood that's here that I'm going to end up using. Anyway, let's do it. Now, there's always a checklist that I go through when it comes to setting up the machine, and I'm going to start running that checklist. Red control box power switch and key on. press green light button with no tool. So I'm going to turn on the control box. Alright, we're getting the green button is over here on the spindle without a tool. Now we got air there. Press red E-stop, that's got to come out. May have heard the tool click on. And now on the controller I've got, good, I've got power there. Check spindle fan, you're going to want to make sure that you've got, where my hand is, you can kind of see my hand over here, top of the spindle. Shake hands with all 4 motors, really important. As Chris Bird said, you want to be there the day that there's going to be a problem. Motor on the left side is good. Coming over here to touch the motor on the opposite side. You really can't see me doing those 2 motors. There's one here, another one back here. I've got them all checked. Motors are good and solid. Shake hand. Okay, open the software. And we're going to open the software. Software is running. Alright, next thing to do is to do a C3 to home it. C3. I'm going to home the spindle. It's homing the Z-axis first. Now it's homing the Y-axis, and then it's going to come down here to home the Z-axis as well. As Chris Burns said, it always goes back and asks for a second opinion. Now it comes down. Now the machine is, because it's an ATC, it's zeroing at the bed height, and we're just going to zero to the top of the material here. That's what we're going to end up doing for this. All right, so we run our C3 to home it. Now we're going to go down and pick up the tool, and that's a C1. But before I do that, I'm going to do my C5 spindle routine warm-up. And that's probably going to take about 12 minutes to run, but we'll leave it running for that amount of time. Alright, now let's do a C5 and warm up our spindle. Now that spindle's just going to run. I'm going to warm up the spindle. It's literally running. We're going to leave it run is what we're going to do. It's going to require my Z0 plate, which you really can't see. Grounding clamp is going to go right to the bit. I've covered elsewhere why that's important. The collet ended up being untrustworthy to ground to. So, to zero the material surface, I need a Z. C2 is what I need. just zeroing to the top of the material. Okay, we're zeroed now. We're going to put our Z0 plate away, our grounding clamp, our Z0 plate away. Now we're zeroed. We should be at 2 inches above the material surface, so we are. We've got to save the tool path since I haven't done that. Toolpath. Cut apart. We're going to air cut this thing, and we're at our home position. We're going to air cut this now. See what it's going to look like before I cut. Oh, looks good. Definitely looks like it's running accurately. I'm going to say that I'm satisfied with this, and I'm going to stop the air cut, and we're just going to go to cut this. Let's do that. All right, so we're going to record this cutting, get this up and close as much as we can. Cut, we're recording this. I'm just going to use my dust collector for this so we can see the bit cutting. And let's cut the file. This might be the 5th pass, I don't recall. I think it is. Material. Now it's going to do the plate. Here we go. It's cutting air now, as you can see. Sacrifice. Might be pass 1, this is pass 2. One more pass now. Last pass. This is it. Lid is off. That's it. That's what it's going to look like. Now, that's a big sheet of plywood, but I was just using it to cut that prep in. Looks really nice. So, what's now to do? We'll give you a little guess. 3/16 is what we care about. Down spiral. Well, we're coming up. About 20,000 is too shallow on this. About 165, about 22,000 shallow. So you'll notice that we did hear some cutting. The reason we heard some cutting is because I zeroed here. I may have zeroed out here, so I think the bottom line is, well, I don't think. I've encountered this many times in the past, which is why I knew to do this. At the end of the day, where you zero, and when you're zeroing off of the material surface and you're going to a specific depth, this and the bottom of the bit need to be on the same page. So let's get our caliper and let's see what we're talking about here. Place this here for a moment if you'll allow. I want to get rid of, anything in here that's going to corrupt me from having a good dimension. I'm just getting some of that stray wood out of there. Let's test. That's going to be considered accurate. So, I don't remember where I zeroed. I think I zeroed out here, but then I zeroed right here, right near my material. So, obviously it's thicker. It's thicker over here is what I'm thinking. Okay, let's put the piece of equipment in here and see what happens. So that's how you go about setting up the tool if you're going to mortise that stuff. The important part, or the purpose of showing how it's mortised, is to say this is what it needs to look like when it's done, and here's an approach to go about doing it. And then you basically take that knowledge, you use the tools that you have and the skill that you have, and you just get to the same final destination is what it is. Let's wrap up this video with just some additional information about Accurate. Okay, so wrapping this video up, I just wanted to show you some additional information. The manufacturer's page here, you can click here, and you can fire up not only all of the Accurate products that we sell. Sorry, let me get rid of the spindle control. The Accurate products we sell down here, a link to the manufacturer's website here, and then a link to their product catalog here. I would absolutely recommend that you review Accurate and all of the products that they have. And it's because you're not going to buy you're never going to buy your run-of-the-mill material from them. You're not going to buy typical builder's hardware. And that's because that's not really the product line that they're in. Accurate is in the business of doing stuff that no one else gets into doing at all. And what I mean by that is, if you are an installer of finished hardware, you're going to, for sure, at some point, just simply want to scroll through this catalog to get an idea of what they do. A lot of ligature-resistant hardware for swinging and sliding doors, and it just goes on and on. Those folks over there are super enjoyable to work with, and I look to send things their way every single time or chance that I can get. And they're just really interested in making sure that you're a success. Harmon hinges, or pocket pivots, they call these. Harmon is, I think, the proper term. That's how I know them. I know them both ways. Anyway, that's all. Any questions on this accurate transom bolt, please feel free to reach out to us. Thank you.